Welcome back to Haiper Creators. I'm Haiper, and in today's video, we're diving deep into the mysteries of the universe. From the potential of colonizing distant planets to the wonders of moons and stars beyond our reach, we've got a cosmic journey ahead. Don't forget to like, subscribe, and hit that bell icon so you never miss out on any of our epic explorations. Let's get started. Mars, the fourth planet from the Sun, is often regarded as the most likely candidate for human colonization. It has many features that make it somewhat Earth-like, such as day length, polar ice caps, and evidence of past liquid water. Proximity to Earth. Mars is only about 54.6 million kilometers away from Earth on average, making it the closest potential site for colonization. Day length. A day on Mars is 24.6 hours, which is very close to Earth's day, making it easier for humans to adjust. Water resources. Mars has frozen water in its polar ice caps and possibly underground reserves, which could support human life. Possible terraforming. Terraforming techniques have been theorized to create an Earth-like atmosphere on Mars, such as releasing greenhouse gases to warm the planet. Thin atmosphere. Mars has a very thin atmosphere composed mostly of carbon dioxide, with little oxygen for human life. Cold temperatures. The average temperature on Mars is about -60 degrees Celsius, which would make it difficult to survive without proper shelter. Radiation. Mars lacks a global magnetic field, meaning it is exposed to higher levels of cosmic and solar radiation, which could pose health risks to long-term colonists. Gravity. Mars gravity is only 38% of Earth's, which could lead to long-term health issues such as muscle atrophy and bone density loss. NASA's Perseverance rover is currently exploring Mars, studying its geology, climate, and signs of ancient life. SpaceX plans to send the first crewed mission to Mars in the near future, with the goal of establishing a permanent human presence. Can we terraform Mars? Many scientists believe that using greenhouse gases and altering Mars' atmosphere could make the planet more hospitable, though this is a long-term goal. How can humans survive on Mars? Humans could live in habitats with artificial atmospheres or underground to protect them from radiation, and they could rely on local resources for water and oxygen production. Radiation shielding. Building habitats with thick Martian regolith or utilizing underground tunnels could offer protection from harmful radiation. Sustainable habitats. Using three-dimensional printing technologies, humans could construct homes and structures using Martian soil, which could also be used to grow food. If Earth were destroyed, Mars would be one of the first places humanity could attempt to colonize. However, it would require significant resources, time, and innovation to establish a self-sustaining colony. Terraforming and building habitats that can support human life in the harsh Martian environment would be essential. Proxima b is an exoplanet that orbits the star Proxima Centauri, the closest star to our Sun, located about 4.24 light-years away from Earth. Proxima b is in the habitable zone of its star, meaning it could have conditions suitable for liquid water, which is essential for life as we know it. Proximity to Earth. At only 4.24 light-years away, Proxima b is the closest potentially habitable planet, making it one of the most promising targets for interstellar colonization. Potential for water. The planet is in the habitable zone of its star, where liquid water could exist on its surface if the right conditions prevail. Earth-like conditions. Proxima b is similar in size to Earth, with a similar gravity and potential for a rocky surface, which makes it a good candidate for human habitation. Proximity to Proxima Centauri. Proxima Centauri is a red dwarf star which emits frequent solar flares and high radiation, potentially making Proxima b's atmosphere unstable or dangerous for life. Extreme temperature variability. Proxima b's proximity to its star means it could experience extreme temperature fluctuations. One side of the planet may be perpetually heated, while the other could be frozen, creating an inhospitable environment for human colonization. Lack of detailed information. Because Proxima b is so far away, scientists are still uncertain about its exact surface conditions, atmosphere, and whether it has liquid water. The Breakthrough Starshot initiative is a proposed mission to send small, light-powered spacecraft to Proxima b and other nearby stars at speeds up to 20% of the speed of light, potentially giving us more data on the planet. Atmospheric studies. If we could study Proxima b's atmosphere closely, we could learn whether it has the right conditions for life and what technologies might be necessary for colonization. Can we reach Proxima b? With current technology, reaching Proxima b would take tens of thousands of years. However, initiatives like Breakthrough Starshot aim to send probes within a few decades. Can Proxima b support life? It's possible that Proxima b has liquid water and could support microbial life, but the harsh radiation environment makes colonization difficult without advanced technology. Radiation protection. Due to the frequent solar flares from Proxima Centauri, colonists would need robust shielding, possibly through underground habitats or magnetic field generators, to protect from radiation. Terraforming. If Proxima b's atmosphere is suitable, future colonization might involve terraforming techniques to stabilize the environment, such as introducing greenhouse gases or building artificial atmospheres. Proxima b offers a possible alternative for human colonization in the event that Earth becomes uninhabitable. However, the long-distance, radiation exposure, and unknown surface conditions present major challenges. Colonization would depend on significant technological advancements, such as faster space travel and radiation protection. Kepler 452b, often called Earth's cousin, orbits a star similar to our Sun, located about 1,400 light-years from Earth in the constellation Cygnus. This exoplanet is roughly the same size as Earth and is in the habitable zone of its star, making it one of the most exciting candidates for the search for life outside our solar system. Earth-like conditions. Kepler 452b's size, temperature, and location in the habitable zone suggest it could have a surface and atmosphere similar to Earth. Potential for life. If Kepler 452b has liquid water on its surface, it could support life. Its Earth-like characteristics make it an ideal candidate for colonization if the right conditions exist. Similar star. The planet orbits a G-type star, very similar to the Sun, which could provide the necessary energy for life and potentially be a suitable location for human habitation. Distance from Earth. At 1,400 light-years away, traveling to Kepler 452b would be an immense challenge. Even with current technology, such a journey would take thousands of years. Uncertainty about atmosphere. While Kepler 452b is Earth-sized, scientists have no definitive data on its atmosphere, surface, or potential for life, making it a speculative candidate for colonization. Gravity and surface conditions. We don't know whether the gravity and surface conditions would be as hospitable as Earth's, as we lack detailed surface data. Kepler mission, the Kepler Space Telescope, provided the initial data that led to the discovery of Kepler 452b. However, more advanced telescopes like the James Webb Space Telescope will be essential for studying the planet's atmosphere and surface in detail. Future missions. If Kepler 452b is deemed viable, sending robotic probes or advanced spacecraft would be the next step in our exploration efforts. Can Kepler 452b support life? While the planet has Earth-like conditions, we don't have enough data to confirm whether it has an atmosphere or water, essential ingredients for life. Could humans colonize Kepler 452b? If it has a suitable atmosphere and resources, it could be a candidate for colonization, but the enormous distance presents significant challenges. Faster space travel. To reach Kepler 452b, we would need to develop spacecraft capable of traveling at relativistic speeds. This could involve concepts like nuclear propulsion or light sails. Terraforming. If Kepler 452b's atmosphere is found to be thin or inhospitable, future colonists might need to terraform the planet to make it habitable for humans. Kepler 452b offers a potential refuge for humanity, but the immense distance and the unknown nature of the planet make colonization a distant possibility. In the event of Earth's destruction, sending robotic probes or advanced technology to study the planet would be a first step, but human colonization would be a far-off dream. The Alpha Centauri system is the closest star system to Earth, located just 4.37 light-years away. It consists of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri, which is the closest star. Proxima Centauri hosts the previously discussed Proxima b, a potential candidate for colonization. Proximity to Earth. At just 4.37 light-years away, Alpha Centauri is the closest star system, making it the most accessible for interstellar travel. Multiple targets for colonization. Proxima b, located in this system, is the most promising planet, but there may be other planets around Alpha Centauri A and B that are yet to be discovered. Resources. The stars in the Alpha Centauri system could provide potential energy sources for future colonies, making it an ideal location for expansion. Distance. While Alpha Centauri is the closest system, it is still 4.37 light-years away, which requires advanced space travel technologies that we currently don't possess. Unknown habitable planets. While Proxima b has garnered attention, the other planets in the system haven't been studied in depth, and it's unclear if they have conditions suitable for life or colonization. The Breakthrough Starshot initiative aims to send small probes to Alpha Centauri using light sails, which could provide more information about potential habitable planets in the system within a few decades. Future space missions. More powerful telescopes like James Webb could help identify exoplanets within the Alpha Centauri system that may be suitable for colonization. What planets are in the Alpha Centauri system? The system has at least one known exoplanet, Proxima b, but the other stars may also host planets yet to be discovered. How can we reach Alpha Centauri? Interstellar travel would require significant advancements in technology, including propulsion systems capable of reaching speeds near the speed of light. Space travel innovations. We would need to develop faster propulsion technologies, such as nuclear fusion or antimatter engines, to reach Alpha Centauri in a human lifetime. Terraforming. If planets in the system are found to have conditions for life, they might need terraforming to support human colonization. In the event of Earth's destruction, the Alpha Centauri system, with its proximity and potential for habitable planets, would be one of the first systems considered for human migration. However, reaching it would require significant technological progress, and we would need to find ways to deal with the vast distances and unknown conditions of potential habitable planets. While Mars, Titan, Europa, and other moons and planets within our solar system provide relatively accessible options for human colonization, stars and exoplanets outside our solar system, such as Proxima b, Kepler 452b, and the Alpha Centauri system, represent long-term goals for humanity. The challenges of space travel, radiation protection, and environmental sustainability make these projects daunting, but with the right technological advancements and international collaboration, the dream of colonizing other worlds could one day become a reality. In the face of a potential catastrophe on Earth, these distant stars and planets could offer humanity the hope of survival and a new beginning. But the journey will require us to solve some of the most difficult scientific and engineering challenges in history. That's all for today, explorers. Thanks for joining me on this incredible adventure across the stars. If you enjoyed this cosmic journey, make sure to like, share, and subscribe to Haiper Creators for more intergalactic content. And, hey, leave your thoughts in the comments. Where do you think humanity should head next? Until next time, keep reaching for the stars.